Hi, Nezra. One more minute. All right, I'm going to get started, and if people join us, great. And if they don't, hopefully they'll at least watch Miss Patel's video that I posted. So my lesson is not going to be very different from hers. If you started to watch it and thought there was nothing there, she seems to log on very, very early. So it's starting around the 8th or 9th minute is when she starts to talk. So be patient, but this lesson will be very similar to hers. In this packet, which is a very, very short packet, I believe we are only going up to page 12 or 14. We are not doing applications of trig functions because we don't have time to do applications of trig functions with only 2 live classes per week. Therefore, in terms of the objectives of this packet, we are only doing restricting domains, relationship between trig functions and their inverses, and we will do a little bit of composition of trig functions, and hopefully you'll remember that when we did our function unit. Your homework for this packet or for day 1 is the worksheet that's already published. I'm sorry if I didn't publish the module. I was so disappointed with myself when people are like, I can't, it's there, but I can't get in it. Ms. Patel's video, this packet, and the homework, the worksheet inverse trig functions. And I will actually do, there's like 26 problems. I'll do at least 3 of them with you so you have an idea what you're supposed to do with that worksheet. Does anybody have any questions before I continue?
Ms. Stein, there's like 2 like worksheets. Which one is it that you said we were supposed to do for homework?
Just the one that's published. There's one that's not published and one that's published. Are they both published?
Well, let me check. Well, I mean, one says homework.
If the one that's
one,
yeah, the one that says lesson 1, that's
no.
Yeah, it's not the lesson 1, it's the worksheet.
Oh, okay. It says WS.
Yeah, WS for worksheet. Yes, sorry about that.
Okay, thank you.
You're welcome. All right, so I'm not going to do the warm up, but I'm just going to remind you that you have got to be comfortable with negative angles. When we're doing inverses, the inverse for tan and for sine takes place in quadrant 4. The fastest way to quadrant 4 is by going clockwise, not counterclockwise. Plus, once we restrict the domain, you will not be able to get values that are, say, 7 pi over 4 or 11 pi over 6. You will not be able to use domain values like that. So you must be comfortable with negative angles in quadrant 4. All right, I already filled everything in, and the reason I did that is so that when I print the notes, because I have limited time, it has everything you need. So the objective here is to graph the inverse trig functions by identifying domain and range. So if you remember from inverses, and remember, an inverse is not a reciprocal. An inverse is undoing. It's also a switching of x's and y values. So this table is sine of x. I took either the unit circle or I took this graph here and I plotted the critical values, the 5 critical values. Actually, it looks like 6. No, it's 5. So then, in order to make our inverse sine function 1-to-1, meaning it passes both the vertical and the horizontal line tests, I must restrict the domain. I restrict the domain between negative pi over 2 and pi over 2. If you look at that yellow part, the red part is the whole sine curve that would be an inverse, but that does not pass the vertical line test. Here I go. I hit the curve here and here. You can only hit the curve once in the vertical line test. So I restricted my domain to only go between negative pi over 2 and pi over 2. Now, I'm going to talk about what that means for the unit circle. But in terms of our switching of the domain and range, I start out with all real numbers for the domain for sine of x. The range pings between -1 and 1. When I switch my domain and range, my domain becomes a range. I'm only going between -1 and +1. But my range is negative pi over 2 to pi over 2, not all real numbers, because when I restricted the domain, that automatically restricted the range as well. So does everybody understand what I'm doing? I'm taking a little piece of the sine curve and saying only that is the inverse. Now, I don't have to choose that. I can choose this. Oop, that's a bad color. I could choose this. I could choose this. But I can only choose a part that lets it be 1-to-1, passes the vertical and horizontal line test. So we're always going to use the yellow one. We're going to go through the origin. That's the one that makes the most sense. I can do the same thing with cosine. I put in my x and y values. I switch x and y to create the inverse. And the inverse, if you remember, has this little -1. And again, I have to restrict the domain. In this graph is the entire cosine curve, but I want it to be 1-to-1. So once again, I'm picking only a part that passes the vertical and horizontal line test. I'm going to go from 0 to pi. So only that is the inverse of our cosine function. Here it is. This is the graph of the inverse. It looks weird, but if you kind of turned it the other way, you could see the blue line. That is the continuation of the cosine curve. But I'm only choosing values for the domain between -1 and 1 and the range from 0 to pi. Questions about the cosine curve. And again, you can see the switching. The range becomes the domain. The range is not all real numbers in cosine -1x, because when I restrict the domain, that automatically restricts the range. You just got to stop me when you have questions. The most important inverse you need is for tan. I guess I don't remember this because I taught calc with apps, honors calc, and I took AP Calc, but obviously a long time ago. I did not remember. I do not remember why it's the most important, but in terms of our inverse trig functions, tan is the one that you really need to know. If you remember with tan, this is tan x. It has vertical asymptotes at -pi over 2 and pi over 2. And the curve goes between those. So graphing tan inverse is actually pretty easy because your vertical asymptotes become horizontal asymptotes, where pi over 2 and -pi over 2. Those values should sound familiar to you because we just used that range and domain. We just use that for sine. Here's the difference. Because tan has asymptotes, when I write my range, I have parentheses, not hard brackets, because I'm including all angles between negative pi over 2 and pi over 2, but I am not including those two angles because of the asymptotes. We'd be working on transformations for these graphs. No, luckily we don't have time for that. So we will not be transforming them. So that being said, the previous page and this graph, you need to memorize. And you need to memorize that sine and cosine are exactly the same in terms of their range, except for including the angles on the ends of it. The ends of it. Do not include those. Before we get into calculating inverse trig functions, I want to remind you that when we are asking for sine of x, we give you an angle and you give us a ratio. This is what we previously did. Given an angle, find the ratio. That's what a trig function is. And it says evaluate. You're giving me a ratio. When we're doing inverses, meaning anytime you see this symbol with your trig function, we're giving you a ratio, and the answer is going to be an angle. But you have to remember the restricted domain. If you don't remember the restricted domain, you're going to pick the angle answer from the wrong quadrant. So I've done one little example here. I've done inverse sine of 1/2. So I've taken the question and I've rewritten it in a format that you might better recognize. Sine of what angle equals 1/2? Well, I look at 1/2 and I say to myself, that's a positive angle. Where is sine positive? Well, sine is positive in both quadrant 1 and quadrant 2. But I told you that in terms of our sine function, it is only valid between negative pi over 2 and pi over 2. So I'm eliminating that second quadrant. I have to use a first quadrant angle. So while pi over 6 and 5 pi over 6 both give me a positive 1/2, this is the only answer I'm giving because it can only be in quadrant 1. Why? Because we restricted the domain to create the inverse. You guys good? Yes? Okay, on this page, I really didn't have much to share, except you will see a lot of teachers use arc sine rather than inverse sine. So anytime you see arc sine, it means inverse sine. And then I wanted to remind you, yes, this graph is dandy. It explains the inverse, the switching of the x's and the y. The thing you really need to use is your unit circle. Anytime I'm asking you about inverse sine or arc sine, in your mind, you are drawing this picture in your head to remind yourself that inverse sine can only be valid in quadrant 1 and quadrant 4. Same thing for cosine, but remember, cosine is looking for the right word, is allowed in quadrant 1 and quadrant 2. That's from 0 to pi. So anytime I'm asking you about inverse cosine, arc cosine, You are thinking of the top half of your unit circle, where the values go between 0 and pi. Arctan, also known as inverse tan. Do not forget the asymptotes. Look at this part of the unit circle. It's the same part as sine. But notice, I have open circles here and here because tan is undefined. I'm sorry, inverse tan is undefined at negative pi over 2 and pi over 2. So same part of the unit circle, exclude the ends. Arctan is the same as inverse tan. Now I put this table here. You don't have to copy it now. Just copy it from the notes. It just sums up what we did on the first 3 pages. This is when we had a lot more time to go over this, but it kind of sums everything up. I not only did the XY graph, I also did the unit circle graph so you can see. And then when you get down here to inverse tan, notice I made these open circles, same as sine, except do not include negative pi over 2 or pi over 2. Okay, so now the next thing I'm going to do is exactly what your homework is going to look like. And I'm going to do the first 3 problems here, and then I'm going to do a couple of the homework problems. So the first question asks for inverse cosine, and it gives you a negative angle. So I rewrite the problem, just because I'm trying to get you guys used to this, as cosine theta equals negative pi over 2. As soon as I see inverse cosine, I'm drawing this part of the unit circle, and I'm saying to myself, where is cosine negative? Cosine is negative in quadrant 2, so I have to use the quadrant 2 angle that gives me negative 1/2. So because it's me and I don't like use 1 as my radius, I drew my special right triangle there. I say in order to get cosine negative 1/2, it's this angle for the reference angle and this angle for the answer. In order to get a ratio of negative 1/2, the reference angle is pi over 3. Therefore, the answer to number 1 is 2 pi over 3. Questions about number 1? Inverse sine of 1 equals theta. Therefore, sine theta equals 1. Remember that sine is your y value. Where is sine positive and 1? Well, this is the only part of sine that I can do. I'm going to do the half circle here. This is where sine is 1. Remember, this is cosine sine x, y. Y is sine is 1. The angle at that coordinate is pi over 2. So it's one of your quadrantals. Remember with sine and cosine, if the ratio is 1, it's got to be a quadrantal. If it's tangent and it's 1 or negative 1, that's a 45, 45, 90, or a pi over 4, pi over 4, pi over 2 right triangle. Number 3, arcsine is just the same. Oops, the same thing as saying inverse sine. So I write inverse sine. There's the ratio. The angle is the answer. I rewrite it as sine of some angle equals negative pi over 2. That means it was negative 1 over, I'm sorry, negative square root of 2 over 2. which means that before I rationalize the denominator, it was -1 over square root of 2. Inverse sine has this part of the unit circle. Sine is negative in the fourth quadrant, so I draw that triangle there. The angle here is not 7 pi over 4. Remember, the angles can only go from -pi over 2 to pi over 2. If you're in the fourth quadrant and you're going clockwise around the unit circle from the positive part of the x-axis, the answer to number 3 is going to be -pi over 4. That's this angle. It's sort of like when we were going counterclockwise, and I said, in quadrant 1, the reference angle is itself. When you're going clockwise and you're using negative angles, it's the same thing in quadrant 4. The reference angle is itself. Okay, last one, some of the homework ones. So I'm going to do 11, 13, and number 19 with you. Oh, did I do? It looked like I did 15 too. Number 11, arc cosine of 2, inverse cosine of 2. Have you ever heard of a ratio that's 2? Have you ever had a ratio that was 2? It might have a 2 in the numerator or denominator, but have you ever had a ratio that was 2? No, that's outside the unit circle. So if it's outside the unit circle, the answer is undefined. Okay, so angles bigger than your normal special triangle ratios. What's angles? Ratios that are larger than your special triangle ratios, those do not apply. And you're just gonna, you don't even have to do anything. You just have to say, that would never work. That answer is undefined. Number 13. Oh, do I want to skip number 13? No, I don't want to skip it. I want to do it. But it's a composite. I want to do number 19 before I do number 15. Okay, so if you remember back when we were doing our function unit, we studied composite functions. That's a function in a function. So in this first set of parentheses, you're going to answer this question, and then you'll worry about sine later. The answer to what I highlighted in pink is going to be an angle, because if it's saying sine of something and not inverse sine of something, it means the answer to this first set of parentheses has got to be an angle. So I'm going to go through my steps of cosine, the inverse of cosine. Inverse of cosine goes from 0 to pi. It's positive square root of 3 over 2. That means a cosine is positive in that first quadrant. If it's cosine square root of 3 over 2, that means this angle here has got to be pi over 6. So now I go back to sine and I say, well, what is sine of that same angle? I'm still in quadrant 1, pi over 2. Ah, why do I keep saying that? 1/2, 1 over 2. Okay, so now I'll go to number 13, and then I will do number 15, and then I'll see if you have any questions. Number 13. Number 13 is not asking for an inverse. It's asking for a ratio, because it's sine of 3 pi over 4. That's sine of an angle. So 3 pi over 4 is in the second quadrant. Remember, this is not an inverse. Sine is allowed in the second quadrant. Inverse sine is not allowed in the second quadrant. So all you're doing in the second quadrant is picking up this ratio. Once you have that ratio, then it wants to go to arc sine. It wants to go to inverse sine. Inverse sine is only positive here. So you are taking this special triangle and you are moving it to quadrant 1. And now you're looking at 1 over square root of 2. So now your triangle is going to be here. If it's 1 over square root of 2, that's got to be a pi over 4 angle in quadrant 1. So sometimes with these composite functions, you're going to start in one quadrant, and then based on the answer in the parentheses and your restrictions on the domain, you're going to have to switch to another quadrant to finish answering the composite question. When you say sine is allowed in the second quadrant, do you mean where sine is positive? So this is what I mean. When I think of my regular sine, cosine, tangent, and all of their reciprocals, cosecant, secant, cotan, all students take calculus. When I think of inverses, I do this. Sine, tan, cosine. And then I say to myself, I'm sorry, these are inverses, sorry. Cosine, positive, inverse cosine, positive here, negative here. Sine, positive here, negative here. Tan, all students take calc. You see how bad I am? Positive, negative. All right, so you're switching. Once you have your answer in the parentheses, in order to meet the restrictions of your inverse, you may need to switch quadrants. All right, so I did number 19. Let's look at number 15. Okay, so 15 is just an inverse tan. It's negative, so that means it's going to be in quadrant 4. If it's square root of 3 over 3, negative square root of 3 over 3, that means it was negative 1 over square root of 3. Tan is negative in quadrant 4. Since it's negative 1 over square root of 3, that means that pi over 6 is this reference angles, which is itself. It's negative pi over 6 because you're going clockwise from your initial ray. Okay, that's it. That's what I've got. My God, I said I would do a half an hour and I made it almost exactly. Watch this video again. Watch Ms. Patel's video. Look at the notes in Google Drive. I will finish the rest of them, the pages, or I will at least print the pages with the notes that I have. And I'm going to take any questions you have before I go. Nora's shaking his head and saying, no, no questions. Taylor, Alex, Carly, Nezra, Jay, John.
Thank you.
Okay, bye.
All right, thank you.
You're welcome. Bye-bye.
you.
Bye. You're welcome.